Now, monotonic transformation is basically saying the following. If I have a utility function of the format log x plus log y, this basically, if I put it into short form, it's basically x into y. So the utility of 1 comma 5 will be basically log of 1 into 5, which is basically log 5. And the utility that I get by 2, 3 is basically log of 2 into 3, which is basically log of 6. Now, since log 6 is greater than log 5, I can say that the bundle 2, 3 is preferred over the bundle 1, 5. Okay. And similarly, if I get another bundle, say 1 comma 4, so log of 1 into 4 is basically ln 4. So I can basically say this. 2, 3 preferred over a 1, 5 preferred over a 1, 4. Now, whether I take log xy or I simply take xy, let the utility be simply x into y. So utility of 1 comma 5 will give me 1 into 5, which is 5. Utility of 2, 3 will be basically 2 into 3, which is equal to 6. And the utility 1, 4 is basically 1 into 4, which is 4. Now from here also I'll get the same thing, 1, 5 inferior to 2, 3 and 1, 5 is superior to 1, 4. See, ultimately the result is the same. You can write this in big letters. The result, whether I take log xy or I take only xy, isn't the result coming out to be the same? Do we get the same thing? Do we get that the order is the same? Here the conclusion was 2, 3 is greater than 1, 5 is greater than 1, 4. And here also the conclusion is 2, 3 greater than 1, 5 greater than 1, 4. Right? So the conclusion is the same. The result is the same. Whether I take log xy or I take only xy. So I can write down any monotonic transformation. What is a monotonic transformation? Which leaves the ranking or the order unchanged. Ranking or the order unchanged ka matlab, it means that if earlier on k was greater than L, then if I take any monotonic transformation, say Fk will again be greater than Fl, where this F is the monotonic transformation. An example is log, an example is e to the power, an example is multiplication with a positive constant, an example is adding any value to it. So these are all examples of monotonic transformation. Ranking or order is unchanged. Any monotonic transformation of utility function can be considered in the ordinal framework for finding optimal xy for the consumer. So any monotonic transformation of the utility function can be considered in the ordinal framework for finding the optimal xy for the consumer. So any monotonic transformation is allowed. Any monotonic transformation is allowed. Okay. This makes calculation extremely easy when we come to the third aspect, which is calculating the optimal xy. Okay. So let's do a very quick recap. We understood the aspect of the economist who basically laid down all the properties of the preferences of the consumer. He went to the mathematician gave him a utility function, then they discussed with each other whether we should be considering a cardinal or an ordinal framework. Most of the economists went in favor of the ordinal framework. Whenever we have a question where nothing is mentioned, we will consider the ordinal framework. Okay. In the ordinal framework, we saw that only the ranking is important, only the order of the preference is important. So if only order of the preference is important, I may choose to make my problem easier by taking a monotonic transformation of the utility functional format, getting it into a more understandable format. Like a log xy, I can easily write as only xy because it is an easier framework to deal with. Okay, I simply multiply xy and I find out which bundle is preferred over which. Okay, right? So any monotonic transformation leaves the ranking or order unchanged. So this is about the preference of the consumer. This is about how the utility function is built on the preference.